Alright guys, today we're going to talk a little bit about systems of equations. Now, I see some puzzled looks on your faces because you're thinking, we've already done systems of equations. And you are correct. Remember doing systems of equations in Unit 3? That was our big project out in the hall with the QR codes. Remember those? So when we did systems of equations, there were 3 ways that I taught you to do them. There were really 4, but we're not going to pay attention really to that last one. What were the 3 ways I taught you to solve systems of equations? Substitution was one. Elimination was one. That's the one we're not going to pay attention to. I know, we can't use it this time though. So what's the other way? Start to the G, and it's not gangsta. Oh, graphing, yes, okay. So elimination, substitution, and graphing. Those were the 3 ways that we talked about solving systems of equations. You are correct that we did talk about matrices, using matrices to solve systems of equations with reduced row echelon form and stuff like that, but we can't use those for these kind today, so we're not really going to focus on that at all. Okay? So when we had 2 lines, like this and like this, what were we looking for? The point of intersection, right? This was the solution. Where those 2 lines crossed was the solution. Okay? So here's the difference of what we're doing today. Same thing as before, except today we might start with a parabola. And then if I have a line, what are my different opportunities? What are my different choices here? Well, the line could go like this, right? How many solutions would that be? 1, 2. The line could go like this. How many solutions is that? 1. Or the line could go like this. 0. So what would I write? No solution. Nah fam, right? Okay. So the fun part comes when I start with a parabola. I'm not going to try to I'll do the first one on a coordinate plane, but the second one I probably won't even try that. If I had another parabola here, how many solutions could I get? Well, I could get 2, right? So if this one opened this way, I could get 1 here and 1 here, right? What else could I have? 1 solution. So how could I get 1 solution? Okay, so it touches right here at the vertex. Or that's right, if there was 1 here and 1 here, right? There's still only 1 solution right there. These aren't going to curve back on each other and touch each other again, are they? Okay, what else could happen? So I could have 1 parabola here and 1 parabola here, so that would be no solutions. I could have 1 parabola here and 1 parabola here, right? What would that be? No solution. I could get 2 solutions other ways. I could have a real narrow parabola, and then I could have a wide parabola facing the same way. That would give me 2 solutions, right? What else could I have? Think outside the box a little bit. We could have 4 solutions, couldn't we? How could we have 4 solutions? Yeah, if it's sideways, right? If it's a non-functional parabola, could I have 3 solutions if it was a non-functional parabola?
Yeah, the bottom of the second parabola could go below the bottom.
So, unless it does like this, the vertex right there, 1, 2, 3. Let's not talk about touching the butt, okay? That's Nemo. Nemo's not in this class, okay? Oh, you mean the vertex. Okay, vertex, okay? You could have 2 solutions that way. Why do I keep drawing that? It could go just like that, right? 1, 2. It's just a lot, right? There's just a lot of them. So I wanted you to see a variety of different ones. I'm not trying to overwhelm you. I just wanted you to see a variety of different things, right? And these are all if you have two parabolas. We're not going to start talking about if we have like a square root function or if we have a cubic or a quartic or something like that. We're not going to talk about that. That's not our bell.
That was a long bell. What does that mean?
I think it's just the wrong bell. Okay, so I'm going to keep going. Okay, so these are all possibilities, yes? Everybody okay with that? So then let's see what it looks like when we have to do it algebraically. Okay? I would like to do this problem using substitution. Let's solve this problem with substitution. Okay? First of all, tell me what shapes they are. What shape is this? That's a line, and this is a parabola. That's exactly right. Okay? So think in your mind, what are our possibilities? We could have two solutions, we could have one solution, or we could have no solutions, right? Okay. Can we have three? You're positive.
Yes.
Good. Be positive. Okay. So if I'm doing this by substitution, and I know y equals this, and y equals this, doesn't this equal this?
Yes.
Okay. So I'm going to go ahead and write that down. X plus 4 equals x plus 2 squared plus 1. Now what? Yeah, I need to multiply it out, don't I? Okay, so x plus 4 equals, God bless you, x plus 2 times x plus 2 plus 1. Well, how do I do this? Distribute, right? FOIL, okay? So x squared plus 2x plus 2x plus 4 plus 1.
Students, please disregard that bell. This class will be over at 10:16. Thank you.
Now what? Combine our like terms, right?
Please disregard that bell. This class will be over at 10:16.
There's 1. Those are the things I have to combine, right? X plus 4 equals x squared plus 4x plus 5. Everybody okay with that? Sorry, you can't really see that on the screen. So those are like terms that we have to add together, right? Okay. Now what? Why? So I could get it equal to 0, right? Okay. Minus 4 minus, whoop, not there. Minus 4. Can I move x also? In fact, I do want to, don't I? Don't you want to? If I'm getting it equal to 0, I need everything on one side of the equation. So I have x squared plus 3x plus 1. So this is a quadratic. What are the 5 ways that we know to solve this? We can graph it. We can factor it. We can square root it. We can complete the square. Or we can use the quadratic formula. Okay? You want to use a formula? Okay. Here's A. Not yet. Here's B. Here's C. Okay? Ready? X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Hey, did you see what I did? I already squared B because I know what 3 squared in my head. Yes, you are allowed to do that. Okay? Not in here. Okay? Negative 3 plus or minus the square root of? Does anybody know what 4 times 1 is? What is 9 minus 4? 5. So now we're done, right? All the way done? Why are we not done? We don't know the square root of 5. That don't mean nothing. What's my goal? In this problem, what is the solution? In this problem, what is the solution? The points of intersection, right? What do I know so far? The x-coordinate of the solutions. So I know my answers are going to look like negative 3 plus the square root of 5 over 2, comma something, and negative 3 minus the square root of 5 over 2, comma something, right? These are going to be my solutions over here, not this. This solves a quadratic formula, right? That's good. That gives us the x-coordinate of the points of solution. Points of intersection, excuse me. How are we going to go about finding the y-coordinates of these points? Yeah, we got to plug it back in. We got to substitute it back in, right? If I know y equals x plus 4 and this is x, what do I have to do to find y? Add 4. So y equals x plus 4, I do. I have them both written here. Okay, so let's put this one in for x. Y equals negative 3 plus the root of 5 over 2 plus, I don't want to write 4. How about 8 over 2? Why would I write 8 over 2? Common denominators. Isn't that equal to 4? Okay. So I just skipped a step there. Is everybody okay with that? I could have written 4 here and then the next one gotten the common denominator. Now I need to add everything in the numerator since I have a common denominator. What do I combine? Negative 3 and 8 is what? So 5 plus root 5 over 2. So when I put in negative 3 plus root 5 over 2, I get 5 plus root 5 over 2 as my y-coordinate. You okay with that? I have to do it again. So let's do it again and I'll answer that question. Fair enough? I have to do it again with this x-coordinate, don't I? Y equals x plus 4, and I know my x this time is this one. Negative 3 minus root 5 over 2 plus 4, which I know is 8 over 2. Now that I have a common denominator, I can add the numerator. What does that give me? 5 minus root 5 over 2. So when I use this x-coordinate, I get 5 minus root 5 over 2. Okay, now let me answer the other question that was being asked a minute ago. Why did I choose to use y equals x plus 4 instead of using y equals x plus 2 squared plus 1?
Because y equals x plus 4 is simpler.
Yeah, this is way more complicated. This is way simpler. Okay, would I get the same answer if I used this one? Yes, I would. This one's easier, though. That's why we chose the top one to use instead of the bottom one, to find the y-coordinate. You okay with that? So what would happen if I graphed these two? It would be a line and a parabola. How many places would they intersect at? 2. So it would look something like this blue line with the red line through. It has 2 points, right? And the first place they would cross is negative 3 plus root 5 over 2, comma, 5 plus root 5 over 2. And the second place they would cross is negative 3 minus root 5 over 2 as our x-coordinate, and our y-coordinate would be 5 minus root 5 over 2. Now, guys, does this really mean anything to us right now? Would it make more sense on the graph if I actually had the decimal for these? But is that required here? No, it's not. When is it required? When I ask you to, like if I ask you to round to the tenths or hundredths or thousandths or something like that, or if it needs to really make sense, like if it's in a word problem, right? We need the actual decimal number answer for it to make more sense to us. You okay with that? Any questions about this? Okay, so what would we do if I ask you to solve this with elimination? Could we do that problem? What if I wanted to solve this with elimination? So ignore this stuff over here. We want to redo this problem with elimination. Elimination, what am I trying to do? Eliminate a variable, right? So I already have y and y. Couldn't I add these two together if one of these was an opposite number, and wouldn't that go to 0? So what if I changed the problem, not changed it? Well, tell me what I did. I multiplied everything in the top equation by -1. What if I now combine it with the bottom equation? Can I directly combine it just like this? I really can't, can I? So this needs to be -y minus x equals -x minus 4, and I need to multiply that out, don't I? Y equals, and I did that a second ago. Can we just go with that? Okay, so x squared plus 4x plus 5. Now we know this multiplied out is x squared plus 4x plus 4, but I have that plus 1 right there, don't I? Okay, now what happens if I add these two equations together just like they are? What happens here? That's 0, isn't it? What happens here? This is x squared. I have a -x and a positive 4x plus 3x, a -4 and a positive 5. Oh my goodness. Look. It's the exact same thing, isn't it? Okay? So depending on which one you're more comfortable with, or depend on what it asks you to do, does everybody understand the steps they would need to do for substitution? And does everybody understand the steps they would need to do for elimination? Okay? Here's the interesting part here. I didn't have to eliminate all but one variable, did I? I had to eliminate the y's and have x's left over, or I'll have to eliminate the x's and just have y's left over. I can't just eliminate like x squared and have x's and y's, can I? That would be kind of weird. Okay? But either eliminate all the x's or eliminate all the y's so you get to an equation like this where you know how to solve that. All right? Any questions about that? I don't need to finish this, do I? I do? Okay. There you go. Done. We already did it, right? Okay. We already did it. Okay, remember we used the quadratic formula for this to solve this, and these are our two answers that we got. Okay? Any questions about this?